Okay, click everything closed and have a quick look. We'll go through a couple examples, and I should be able to give you a fair amount of time to work today. This is the last stuff we're doing, so compound transformations. So this means we're going to do a bunch of stuff all at the same time, right? So before we do that, let's just quickly review from yesterday. What does it do? How does it reflect a function if I multiply outside the whole thing by -1? Over the x-axis is correct. What about if I multiply just the x inside by -1? Over the y-axis. Okay, good. So today we want to look at this stuff. All this stuff combined, if we're doing some combination of everything we've talked about for transformations. A is the vertical dilation factor, so we'll deal with that. And then h and k are pretty simple, right? That's just the translation. They're just going to tell us where that special point or the vertex gets dragged to, right? A, remember, it's the vertical dilation factor. So by definition, if I multiply A times the parent y-coordinate, it's going to give us the dilated y-coordinate, right? Or another way of thinking about that is A is always equal to the ratio of any dilated y-coordinate divided by the corresponding parent y-coordinate, okay? And if A is negative, then all that means is when we do our dilation, we'll also do a reflection vertically, right? So if A is negative, we would do the normal stuff we would do. We would dilate the graph first, and then we would translate it to its final location with h and k, right? That's different than what we did here, though. If I multiply the whole thing, so everything in parentheses, the entire function, including k, the whole thing, if I multiply the whole thing by -1, then remember what that does is it takes the finished expression, so I've already dilated it and translated it, and then after I've done all that stuff, the final product, I just flip over the whole thing over the x-axis, right? And then, of course, if I just multiply x by -1, you already told me that reflects over the y-axis, right? So let's try a couple of these. So there's three kinds of problems that you're going to be expected to do on the test and on this assignment, essentially. If you can do these three kinds of problems, you're in great shape. And they're not hard. They're really not. It's a lot of stuff to pull together, but this group, man, I expect you guys will do great on this. So we got to do them in order, though. So let's just take these things in order, and I'll just kind of color code each step. So the first step we'll call the red step. We're starting with our parent graph, which is f of x. And the first step is we're going to vertically compress the parent graph by a factor of 1/5. So what does that look like? Based on that one step, g of x would be what? What do I have to do to vertically compress by a factor of 1/5? Say it again. Right here?
You would put one, oh wait, I was gonna answer that.
Go ahead.
Oh, 1/5, in front of the absolute.
There you go.
X plus 10.
Okay, so let's just do, I'm just going to do just that part first. So the red part, if I vertically compress, I'm going to multiply outside by 1/5, right? You know what let's do? I'm going to even skip this one. This is too easy. We'll do this one instead. Start over.
Okay, that would be
So we're going to vertically stretch by a factor of 5. We'll just do one example instead of two then. So kind of on this kind, so we'll get you going a little faster. So go ahead, Dave. What's that one going to be?
-5, and 3.
Okay, so you're looking ahead. If we just do the red part, we're going to get 5 multiplied outside, okay? Okay, then if we do, let's call the next step the reflecting step. If we reflect vertically, all that's going to do is it's going to make a negative, right? So combined, those two steps, the blue step just looks like this. And I guess if we combine those two things, what they're telling us is that A equals -5, right? Okay, next step, that'll be, how about the green step? If we translate right by 1, what's that going to do? Okay, x minus 1, so we're subtracting, h is equal to 1, and we're subtracting that from x. Everybody agree? Okay, so we end up with g of x equals -5 times f of x minus 1, and that's the step that's telling us h equals 1. And then finally, last step, make it yellow, how about? If we go down by 6, subtract 6.
It's just subtract something.
Outside. Good. And so there's, well, I'll just stick that on the end, right? So there we get k equals -6, right? And that's it. Okay? All right, so what about something, whoops, I guess these are all, I gotta pull these ones up off of Moodle. But let's look at a couple other examples here. So what if we do something like this guy? How about, ooh, that's a tough one. Okay, you can do it. Okay. You guys are up for the challenge, I think. I really do. So we gotta find the graph of that. We gotta graph that guy. So start off, we gotta think about what's the parent graph here? What are the values of A, H, and K? Tell me that first. So, okay, so the parent graph would be absolute value of X. Everybody agree? If I get rid of all the parameters, all I'm left with is just an absolute value of X. So our parent graph is gonna look like absolute value function. Doesn't that just look like this? It's gonna start at the origin and I go over by 1 and up by 1, over by 2, up by 2. So there's the right leg. What's the left leg look like? Reflection, very good. So it's going to look like that. So there's absolute value of X graph. What's the value of A? -5/4. Okay, so then that's telling me that I'm going to multiply all of my normal Y values by -5/4, right?
Yes.
Make sense? So let's look at those. Now, this is going to have a Y value of 1. That's not going to be very convenient, right? If A is equal to -5/4, I want to multiply by a number so that the 4 divides into it evenly, right? So I don't end up with a fraction. What's the first number that'll do that? 20 would work. 20 is pretty far out there. What's another one that would work? A closer one. 8 would work. What's even a closer one? 2 wouldn't work. 2 over 4 wouldn't go away, but say it again. 4 would. Yeah, let's pick 4. So if I go over 4 and up 4, there's the point with a Y value of 4, right? And so if I want to find, that's the parent Y value though, isn't it, right? If I want to find the dilated Y value, I'm just going to multiply the original parent Y value times A. So we're going to end up getting -5/4 times 4. And what's that give me? -5, right? So we need to go over by 4 and down by 5 instead, right? So that's going to be the shape of our graph, right? So it's going to look like that. So that stretched it just a little bit, didn't it? I multiplied by something bigger than 1, so it slightly stretched it and it reflected it. But then what's the other thing I've got to do? I got to translate. So what are the values of H and K?
2.
Okay, so H is -2, right? Because that's the number that's being subtracted from X, and K is +3. So we'd have to take this thing and we'd have to move it backwards 2 and up by 3, right? Okay, so let's do that. So I'm going to just erase this stuff so it's easier for us to see. So we'd go to this point, the point with coordinates -2, +3, and from there we're going to go over 4, we said, and down 5, correct?
Right.
So there's going to be our other point right there. Same thing over here. I go back 4 and down 5. So right there, okay? And we just have to find that graph, don't we? I guess I need to make this leg, don't I? So let's just go find that one. Not quite, right? It's the wrong slopes. It's supposed to be -2, +3, so it's the wrong location, wrong location, wrong location. Ooh, that looks promising, doesn't it? Oh, what do you know?
It is.
That's it, huh?
Yep.
Okay, so that's the one we want right there. Okay? That makes sense?
Yes, it does.
Okay. All right, so we got that guy. Let's try, how about, I'll tell you, this group is so strong, I'm gonna give you the ultimate challenge. You up for the ultimate challenge? Oh, I think you are. Oh, how about that one? Okay, so, what's that? You ready for this? All right.
Wait, can I even have negative?
Yeah, you can, right? But now let's think about how we're gonna do this one. So what are the values of A and H and K here?
A is 1/5.
Anybody agree? A is 1/5. How about H and K?
No, it's 5.
5.
5/6.
Good,
So you
okay.
just times the whole thing.
But then what does, here's the other part then. What does after we've graphed that whole thing, what's that negative gonna do? Reflected horizontally, good. Okay, so first we gotta do this guy though. Let's take a little shortcut in drawing, in graphing this part of it first, right? Let's just start at the vertex, move the vertex to 5, 3, right? So we're gonna move it over to here. So we go over 5 and up 3, and that's gonna be our vertex. Okay, so what's our parent graph here? Wait, but, it's an x squared, isn't it? Right? If we get rid of, if the a and the h and the k all were to go away, we would just end up with just an x squared, wouldn't we? Right? So our parent graph is x squared. Now let's think what an x squared graph looks like. When I go over 1, I go up by 1. If I go over by 2, I go up by 4. If I go over by 3, I go up by 9. So that's not even gonna, so I'm gonna get, so it's like right there, over by 4, clear up here by 16, right? And if I go over by 5, I'm gonna go up by 25, right? So A is 1/5. Which of those y values would be best multiplied by 1/5? 1, 3, oh, sorry, 4. I'm not doing 3. 4, 9, 16, or 25. 25 would be the best, wouldn't it? Right, so that's the point I really want to use, isn't it? I want to use this point. Okay, so instead of, I need to get rid of all the others. So instead of going over by 1, 2, 3, 4, 5, and going all the way up by 25, we're going to go up by A, which is 1/5 times 25, and what's that? 5. Okay, so we're only going to go up 1, 2, 3, 4, 5. So there's going to be that point, right? And our graph is just going to look, it's going to be kind of a wider version, isn't it? Right? Everybody agree? That takes care of all that stuff, doesn't it? We got our vertex, and we've squished it so it's only 1/5 as tall, right? Now, what does that do, though? Reflects it over, right? So now we got to get the reflection over the y-axis, and what's that going to look like? So instead of going over 5 and up 3, I'm going to go back 5 and up 3. But otherwise, the shape looks the same, right? So I'd end up going over by 5 and up by 5. 1, 2, 3, 4, 5. So and back by 5 and up by 5. So that's the one we need to find, isn't it? So those coordinates should be -5, 3. Let's pick one other point that we can make sure we match up. So if I'm going -5 and back 5, that's going to be -10, and then up by 5 would give me 8. Everybody agree? That's the one we got to find, right? Okay, so tell me when. That's right, the wrong shape. right location, wrong shape. Wrong location, wrong shape, wrong. Ooh, what do we got there? That's it, isn't it? Right? We can see that it's going through key points. Okay, and it's got the right vertex. Everybody agree? Okay. Last one you got to know how to do. So if you can do those, you're great. Check that. We got it, right? Yeah, we got it. Okay. And then finally, something like that. Okay, and I picked like the hardest one I could. That's like this. So we're going to work backwards. Now they're going to give us a function, and we got to write. They give us a graph, and we got to write the function. So essentially, all we have to do is fill in the values of a, h, and k, and we're done. Right? What are the easy ones to do here? H and k are simple, aren't they? H and k, we can get. Those are just the coordinates of the vertex, right? And the coordinates of the vertex are what? 5, -1. So that's just HK, right? So we got those. But we got to do the dilation factor, vertical dilation factor A. So they did give us a convenient point here. So if we go over by, what are we going over by? 5, yeah. So if we go over by 5, normally we would go up by how far? To some point way up here. Yeah, 25, so at some point like way up here. Normally we go up 25. How much are we going up?
5.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, which one is the undilated y value? Okay, that one is, right. So 25 is the undilated y coordinate. That's the undilated amount that the function's increased. We'll call it the y coordinate, right? Which one's the dilated y coordinate? The 10, right? So what do we say about A? A always equals the dilated. So the final one, the dilated y coordinate divided by the parent y coordinate, right? So we can figure it out just by using that ratio, can't we? So A equals 10 over, oops, wrong color. $25. What does that reduce to? 2/5. So there's A, right? So our answer then, if we had to write this out in this form, wouldn't our answer just be f of x equals 2/5 times x minus 5 squared, right? Because it's a squared function. That's our parent graph. Minus 1. Right? Everybody agree? Go. You got it. You can do those things. You got everything you need.